So you mean like loss of energy, right?
Yeah. Yes.
So why does the let me ask you one question. Why does the motion of a simple pendulum oscillating in air die out?
There's going to be like air resistance, and there's friction going to be like small amount. Like at some point, these forces would slow it down enough to make it stop.
Alright. So this happens as the air drag and the friction at the support opposes the motion of the pendulum and dissipate its energy gradually. Okay. So the pendulum is said to
Right.
dissipate its energy gradually. So the pendulum is said to execute this damped oscillation. Okay. This happens. The question is why does the motion of a simple pendulum oscillating in air die out, right? So this happens due to air drag and friction, all right, which opposes the motion of the pendulum and dissipate its energy gradually. Okay.
Okay.
So the pendulum is said to dissipate its energy gradually. So the pendulum is said to execute damped oscillation. So the energy of the system gets dissipated continuously, but the oscillations are approximately periodic for small damping. Okay.
All right. Yes.
Let's say this was the first cycle, and as drag force and friction acts, the oscillations will become smaller and smaller, right?
Right.
And eventually it will die out. But approximately time period, or you can say they are still periodic. Okay, this one is also periodic, this one is also periodic. Are you getting my point?
Yes.
So the nature of the surrounding medium decides the damping force. Okay, nature of the surrounding decides the damping force. The damping force is much greater when the block is immersed in a liquid. Okay, when the block is immersed in a liquid. So it is generally proportional to velocity of the bob, okay, and acts opposite to the direction of velocity. Yes or no?
Yes.
This damping force is generally proportional to velocity and it acts opposite to the direction of velocity. So if the damping force is, let's say, Fd, okay, so it is given by minus b multiplied by v, okay, where b is the constant, okay, and it depends on the characteristic of the medium and also size and shape of the block, all right. So thus the total force acting on the mass at any time is given by first one is minus kx as usual and then this extra force, that is our damping force. Are you getting my point?
Yes.
So we can write this force as ma is equal to minus kx minus bv. Yes or no? And what is
Yes.
acceleration? Acceleration is nothing but double derivative of displacement. Yes or no?
Right.
So we can write it as m d square x by dt square is equal to minus kx minus bv. Yes or no? So
Yes.
eventually it will become m d square x by dt square. We are taking all this term to left hand side, so it will become positive. This is become to this will become 0, right? And we can write this velocity as dx by dt. Yes or no? This
Yes.
equation will become d square x by dt square plus b multiplied by dx by dt plus k of x is equal to 0, right? So this is basically an quadratic equation. Yes or no?
Yes.
No, it's not a quadratic equation. Okay, quadratic
Oh, okay.
equation is ax square plus bx plus c. Here x square term is not present. Okay, so the solution of this equation, this is called differential equation. Okay, and the solution of it is given by a e raised to minus bt upon 2m cos omega dash t plus 5. I'm not writing its solution, its derivation, because it is not important. Okay, and here
Okay.
this omega dash angular frequency is given by under the root k by m minus b square by 4m square. This result is important. Okay,
Okay.
so as you can see, it has an exponential term, so it will exponentially, its displacement is exponentially decaying, right? So if we want to make a graph, okay, so it will look like this way. This is 0, this is minus 5, let's say, this is minus 10, this is 5, this is 10. This axis represents time, then the graph looks like this. Okay, yes or no?
Okay.
Always remember mechanical energy of undamped oscillator is half k square, right? As we have discussed earlier. This is for the
Right.
undamped oscillation. But for the damped oscillation, total mechanical energy is given by half k square e raised to minus bt over m. Okay.
Okay.
So from this equation, we can see that total energy of the system decays exponentially, right? Decreases exponentially with time.
Right.
So this was the discussion on damped oscillation, where we found out that due to air drag and friction, the oscillations, gets smaller and smaller. And after all, after some time, the bob will eventually stop, right? So damping force is generally directly proportional to velocity. So that's why damping force is given by minus BV. Okay.
Okay.